In this short video, I'm going to talk you through some of the calculations in Lab M. I'd like to do this because I find that sometimes students get a little confused or mixed up about these calculations, and unfortunately, they will start off on the wrong foot. And when this happens, then what inevitably occurs is that the rest of the calculations are done incorrectly, and unfortunately, the students arrive at the incorrect conclusions. At the top of page 67, you can see that I have shown the concentration of the stock solutions for the iodide, for the persulfate, and for the thiosulfate. I've also included the main reaction that we're looking at, reaction 1, which shows persulfate reacting with 2 moles of iodide to form the products, including iodine. Our goal here is to find the order of the reaction with respect to the persulfate and with respect to the iodide. In order to do this, we need to know what the initial concentrations are of the two reactants in our reaction beaker. The concentrations in our reaction beaker are not the same as the stock solution concentrations. So I'm going to talk you through the calculation for iodide and for thiosulfate. I'm going to scroll down here a little bit. And first of all, I'd like to point out that in our reaction beaker, we added the 10 mils of the iodide solution, 10 mils of the persulfate, and 10 mils of the thiosulfate solution, and 2 mils of starch. Therefore, our total volume in the reaction mixture was 32 mils. In order to calculate the initial iodide concentration in the reaction beaker, we need to first of all consider the stock solution concentration, which was 0.20 molar, and then we multiply by the volume that we took, and we'll divide by the total volume. Now I realize that when we're working with molarity, we really should be using volumes in liters. But because both of these volumes are in milliliters, the milliliters will cancel and we will end up with units of concentration in molar. When you do this calculation, it comes to 0.063 molar. That's the initial concentration of the iodide in the reaction beaker before the reaction started. You would need to also conduct a similar sort of calculation for the persulfate. By the way, though, this is so far just for system 1. You will also have to, of course, do the same calculation for system 2 and system 3. Given that in system 2 we have the volume of iodide added, you can imagine that the concentration of the iodide will halve. In system 3, we have the persulfate concentration, and therefore its concentration will halve. I also would like to look at the thiosulfate concentration. So note that we start with a 0.0050 molar stock solution of the thiosulfate. We take 10 mils of that solution, and of course, again, the final volume is 32 mils. The concentration of the thiosulfate, therefore, at the beginning of the reaction in our reaction beaker is 0.0016 molar. Note that both of these concentrations are done only to 2 sig figs, given the fact that our original stock solution has only 2 sig figs. So I'm going to write in our thiosulfate concentration right here, but recognize that it's the same concentration for all 3 systems. In fact, it's the same concentration even for system 4 and 5 involving the copper sulfate catalyst. This is important to remember because it is the thiosulfate concentration that will dictate how much iodine needs to be produced before the blue color appears. To show you what I mean, I'm going to scroll down now to the next page, which will be page 68. You will also need to, of course, complete this table. And the idea is that in order to calculate the initial rate, we need to know what the iodine concentration was at the time that the blue color appeared. This concentration is dictated by the amount of thiosulfate that we added. Now we've already calculated what the thiosulfate concentration was at the very beginning of the experiment. I've repeated that value right here. The balanced equation between thiosulfate and iodine is also given. You can use stoichiometry to determine how much iodine had to be generated to consume all of the given thiosulfate. Once all the given thiosulfate is consumed and a little bit of extra iodine is produced, then that iodine will react with starch and show a blue color. Now, normally we do stoichiometry involving moles, but we can also do the stoichiometry involving solution concentrations because our volume stays constant. The idea here is I'm trying to determine the amount of iodine that had to be produced to consume all of that thiosulfate. I start with the thiosulfate concentration, and then I multiply 1 mole of iodine per 2 mole of the thiosulfate. So effectively, I'm simply dividing by 2. The answer here is therefore 0.0016 divided by 2, in other words, 8.0 times 10 to the minus 4 molar. That's the concentration of iodine that had to be produced to consume all of the thiosulfate before the excess iodine reacts with the starch to show the blue color. And this amount of iodine will be the same in all of our reaction systems. So all of these will be identical. Now, I do want to emphasize that this is the iodine product that was produced. We're monitoring how much time it takes to produce that amount of product. Please do not confuse the iodine product that's produced with the iodide reactant that we started with. So we can calculate the initial concentrations of iodide based on how we set up our reaction system. We calculate the amount of iodine that was produced by knowing how much thiosulfate was in our solution and doing the appropriate stoichiometry. Once we have the iodine concentrations and we have the respective average times, we can calculate the initial rates. Once you have that, then this is simply a typical initial rate problem. You have the concentrations of your reactants for system 1 and you'll have its initial rate. You know that you halved the iodide concentration for system 2 and you can look at the effect on the initial rate. And for system 3 we halved the persulfate concentration and you can look at the effect on the initial rate. Remember that the exponents that we're looking for, m and n, will be integers. They will either have a value of 0, 1, or 2. I hope that you have found this video helpful in starting your calculations. Please don't hesitate to ask any further questions that you might have.